All right, today we'll be talking about the malonic ester synthesis. We already talked about it in our previous video and went through the steps of it. So now let's put it into practice, right? Let's use an alkyl halide and see if we can make something interesting, right? So with our malonic ester synthesis, we're going to start with what? We'll start with our ester, our diester, right? And again, we'll do our steps. One will be NaOET. 2, let's do an alkyl halide. Then 3 is H3O plus and heat. Right? And then we can see what we can make from this reaction here. Again, we're not going to worry too much. We'll do the first couple steps. We'll do step 1, step 2 in terms of the mechanism. Step 3, we're really not going to do the mechanism because we've done those before in previous videos. So we're not worried too much about that. But just going to reinforce the idea of what we can do here. Now, let's go ahead and take our ester, and then as we saw before, we're going to use our base. Okay, again, as we saw before, we use our base to pull off that proton. And we get our negative charge there. We make our enolate here. Now we've generated our enolate, right? Enolate's going to attack our alkyl halide. In this case here, we have this carbon 1, 2, 3, 3 carbon chain, our propane, propane. And remember, as we talked about here, this is like an SN2 type reaction, right? So we want to use alkyl halides that are going to be primary alkyl halides. Those are going to work the best, right? Secondary alkyl halides are a little bit tougher, a little bit hindered. Tertiary alkyl halides, no tertiary alkyl halides, right? We're looking at focusing on primary alkyl halides. Think SN2 type reactions. We want to be fast, right? This in our synthesis, we want these to be fast reactions that go to completion. So we're going to want to use our primary alkyl halides. Okay, we get that species there, where we've added in this group here, 1, 2, 3. Again, we need to keep track of our carbons, right? 1, 2, and 3, and we'll write them out here. 1, 2, and 3. 1, 2, and 3, right? We get those 3 carbons. Now, we have these 2 ribbons attached to here. Now, what we're going to do the next step here is we're going to go ahead and add in our H3O plus. And we'll do heat. So again, we'll do this all in one step, H3O plus and heat. Now remember, H3O plus is going to do what? Its job is to convert our esters to carboxylic acids, and then under high temperatures, we're going to decarboxylate. We're going to lose one side. Now, it doesn't matter if we lose this side or we lose this side. Doesn't matter. Either one can decarboxylate. They're symmetrical, so we get the same thing on either side. So let's go ahead and we'll decarboxylate. We'll take that off and make our carboxylic acid. And we end up with our acid here. I'll write this a little bit nicer. Yeah, 1, 2, and 3. And so we end up with this carboxylic acid here, right? Where we have this is our alpha carbon that used to be right there, right? And then 1, 2, and 3, okay? So this is a nice way of basically taking alkyl halide and functionalize it into a carboxylic acid. Not only carboxylic acid here, but we've taken our alkyl halide, we actually added 2 extra carbons. We added the alpha carbon and the carbonyl of our carboxylic acid here, right? Added together to give us this carboxylic acid. That's really nice, right? Taking our diethyl malonate here, functionalize it to make that into a carboxylic acid. So that's pretty cool that we're able to do that, right? It's a nice reaction to get us that carboxylic acid functional group here, okay? So this is just an example of how we can go about doing this here. Most cases, we can do these over 1, 2, and 3. We kind of know what's going on. So I know, hey, I'm going to add this group here, and I know I'm going to lose one of these groups here. Okay? So what's interesting about this is that if we go back to our diethyl malonate, we have hydrogen here, and we have hydrogen here. We actually have 2 hydrogens here, right? That's kind of interesting, right? Because we pulled off this proton. We had a enolate, we then attacked with alkyl halide, we generate this species here, right? Now, once we get to here, we added H3O plus to make our carboxylic acid and decarboxylate. But what if we got to this step here and we added in maybe another base and then another alkyl halide? Can we do that? Let's look at that. Let's see if we can do that, right? That looks kind of interesting, right? So things are starting to get interesting again, right? Again, this time we won't do the mechanism as much. We'll just kind of go through those steps, right? We see the mechanism enough, we kind of know what's going on. O. And so let's think about this. I'm going to do 1, NeOET. 2, let's add an alkyl halide. Let's do something different. I don't know. Let's do this one. Let me go a carbon longer, maybe. How about that? 1, 2, 3, 4. Okay. So we did 1 and 2. So this makes an enolate. This group then it gets attached right there, right? Now, what about the third one? We go ahead and say, okay, I'm just going to add in, I don't know, base again. What's that base going to do, right? Well, it's actually going to make that enolate again. And then 4, let's add in another alkyl halide. Let's add in something like this. We'll put in something like that. How about that, all right? And then what's going to be 5? 5 is going to be what? 5 is going to be our H3O plus and our heat, right? And so we can do that. And so now what we're doing is we're doing this twice, right? We're going to add 2 groups in there. So let's go about through the steps of this, right? Again, we won't do the mechanism. We'll just kind of go through the steps. So ET here. We're going to add in our base. That's going to do what? Make ETO. Make our enolate. And then what? We're going to take the enolate, we're going to react it with 1, 2, 3, 4 with our alkyl halide, as we talked about. All right? We're going to react it with our alkyl halide, just like we saw before. And then we're going to get this here. One, 2, 3, 4. 1, 2, 3, 4, right? So we get to this species here. Now this is the interesting part, right? Let's go ahead and treat it with base again, right? Do our base step again. Add in our base. And what are we going to get? Just draw this like, we'll draw like this. Right, and then we're going to get in our ETO. We're going to make our enolate again. All right, enolate can then attack what? Our alkyl halide. In this case, let's put a different alkyl halide in there, right? Yeah, we want those primary alkyl halides, right? Just like we saw before. And then we get our ETO. One, 2, 3, 4. 1, 2, 3, 4. And then we get 1, 2, 1, 2. So we get this species here, right? And then again, what's going to be our last step? What are we going to do last? Well, we could take this, and I'm running out of board space. We can do H3O plus and heat. What's going to happen? Just like before, we're going to convert the ester groups into carboxylic acids, and they're going to decarboxylate it, right? We're going to lose one of those groups here. We'll get to that, right? And so I'm going to have to erase there because we're running out of room. The board's a little bit small. And we're going to end up with this species here. Oops, oh, there it is. So 1, 2, 3, 4. 1, 2, 3. There's 4. And I'll write that group there. 1, 2, 1, 2, right? So we can see all our groups here, right? Keeping track of all these. Remember, they're all adding to this alpha carbon. This alpha carbon is this alpha carbon here. That's staying there, right? And this is the carbonyl, and that's still our carbonyl, right? Again, I could decarboxylate, and we can lose this group as well and have that one. It'll be the same thing. Doesn't matter which side we decarboxylate. We're going to get the same carboxylic acid, okay? So what's nice about this too is if we do these incorporate these 2 more steps, using base again, and then using our alkyl halide, we can actually add 2 groups in here. Not just one, but we can add a second group in there, right? And then do the hydrolysis with H2O+ and decarboxylation, right? So we can do this over 2 steps so that we can make these functionalized one, right? So we can get what? We can get our carboxylic acid. 1, 2, 3, 4. We can get this molecule here, right? Or this piece here is right here. 1, 2, 3, 4. 1, 2, 3, 4. And this one down here. 1, 2. 1, 2, and then our ring structure here. Okay? So we can use this. It's pretty versatile in terms of that we can add 1 alkyl group here, or we can add 2 if we want to, depending on what we're trying to make, right? What we're trying to get to. So it's pretty useful to adding different groups on there to give us, and then end up with a carboxylic acid functional group. Okay? So very useful reaction. Okay? So this is the second part of our malonic ester synthesis. Now we know kind of how to use it and how we can apply it, right? Big thing here, we use our base, deprotonate, and then we use our, again, primary alkyl halides, right? Primary alkyl halides. And then we're going to use H2O+, hydrolyzed to carboxylic acid, and then heat to then decarboxylate. So we lose one of these groups here to give us just that carboxylic acid, okay? Our malonic ester synthesis.